Okay, hi there. In this session, I would like to talk about bearing capacity and shallow foundation. So before I talk about foundation, let me define what foundation is. Foundation is defined as a part of the structure that transmits loads from the superstructure to substructure, or in other words, to soil. When we talk about foundation, there are two types of foundation. One is shallow foundation and another one is deep foundation. How to differentiate between shallow foundation and deep foundation? Let's say this is a general schematic of a foundation. So the width of the foundation here is known as B, the width. And from the ground surface to the base of this foundation is known as depth of footing or depth of foundation, D sub F. So for a shallow foundation is defined as when dF over B, the ratio of depth of footing or depth of foundation to B is less than or equal to 3 or about 4. So for any foundation with the ratio of dF over B greater than 3 or 4 is categorized as deep foundation. Right? Okay. When we design foundation, we have to make sure that the soil will not undergo shear failure. And then we have to make sure that the foundation will not experience excessive settlement. Okay, in terms of a shallow foundation, there are several equations that we can use to determine the bearing capacity. Right? We have Terzaghi's equation, we have Meyerhof-Hansen equation. Terzaghi formulated 3 different equations for bearing capacity of shallow foundation depending upon the shapes of the footing or the shapes of the foundation. One equation for strip footing, meaning the ratio of the width of the footing to the length of the footing is very, very small, meaning the length of the footing is very large. Second equation is to be used in calculating the bearing capacity of a rectangular footing. And another equation that can be used to calculate bearing capacity using Terzaghi's equation is for circular footing. So, as a summary, we can use 3 different equations based on Terzaghi's theory depending upon the shape of the footing. Another equation that can be used to calculate bearing capacity of shallow foundation is Meyerhof-Hansen's equation. Right. So in this session, let me talk about Terzaghi's bearing capacity equation. Okay, before we move on to look at examples in using different equations to calculate bearing capacity of soil, it's good if everyone of you have this kind of book, right? Because we have to refer to certain equations and tables in order to calculate the bearing capacity using different equations. If you don't have this book, you may refer to any geotechnical engineering textbook. Okay? Let's move on to the first example in using Terzaghi's equation to calculate bearing capacity of shallow foundation. Okay, in addition to this book or other geotechnical engineering textbook, I would like everybody to have sheets of paper with pen or pencil so that we can solve the given example together, because I'm going to show you step by step how to solve this problem. So before we start solving this problem, I would like everybody to draw the diagram and to write down the problem statement. In this problem example, we have a shallow foundation, which is a square foundation, 2 meters by 2 meters. And the depth here, I forgot to write here, the depth of footing D sub F is equal to 1.5 meters. Okay. And then these are the soil properties, where we have the unit weight of the soil equals to 18 kilonewton per meter cubed. The internal friction angle equals to 30 degrees, and the cohesion of the soil equals to 30 kilonewton per meter square. So, in this example, we have to use Terzaghi's equation to determine the following. A. Allowable bearing capacity with the symbol of small q sub ALL, Q allowable. B. To determine the net allowable bearing capacity with the symbol of small q sub net ALL, Q net allowable. C. Allowable load with the symbol of capital Q sub ALL, that's allowable load. And D. Net allowable load with the symbol of capital Q sub net allowable. To solve this problem, we have to use safety factor Fs equal to 2.5. If you refer to this book, right, you go to page 22, and then you will find 3 different equations based on Terzaghi's theory. One equation for straight footing, second equation for rectangular footing, and the third equation for circular footing. You may refer to other geotechnical engineering textbook. The equations are approximately the same. Okay. So, based on those 3 equations, we have, or you have, to select the appropriate equation to solve this problem. So, if you look at the dimension of the footing, is a square footing. There's no, in the book, I'm referring to this book, there's no specific equation for square footing, but we have to remember that square is a component of rectangular footing. So we have to refer to rectangular footing equation. This is the ultimate bearing capacity equation that we have to use to solve the given problem example. Okay. So Q sub U, the ultimate bearing capacity, is equal to, parenthesis, 1 plus 0.3 multiplied by B over L multiplied by C n sub C plus Q multiplied by n sub Q plus 1/2 multiplied by 1 minus 0.2 B over L gamma B and gamma. So this equation is for rectangular footing. Since we have square footing, in this case, B over L is equal to 1 for square footing, meaning the width and the length are equal. Okay? So when we have B over L equal to 1, then we have to rewrite this equation. So this equation becomes 1 plus 0.3, B over L is equal to 1. So 1 plus 0.3 is 1.3, C multiplied by n sub C plus Q and Q plus here 1 minus 0.2 multiplied by B over L is 1, so it becomes 1 minus 0.2 is 0.8. divided by 2, we obtain 0.4 gamma B in gamma. So this equation that we are going to use to solve the problem. Right. Here we have a group of items in this equation. So 1, 1, 3, C and C, I call it as C term. Whereas here, Q multiplied by N sub Q, I call it as Q term. And 0.4 gamma B and gamma here, I call it as gamma term. Okay. So, refer to your book, right, in order to obtain the value of bearing capacity factors for Terzaghi's equation, which depend on the value of internal friction angle and sub C and sub Q and sub gamma. So, for friction angle equal to 30 degrees, you refer to table. If you use this book, then you have to refer to page 59. There's a table which tabulate the value of bearing capacity factors based on Terzaghi's equation. Right. So for internal friction angle equal to 30 degrees, N sub C is equal to 37.16, and sub Q is equal to 22.46, and N sub gamma equal to 19.13. Okay, so before I forget, here is for square footing. Okay, after we have obtained the values of bearing capacity factors, then we insert this value into the ultimate bearing capacity equation, as well as other soil parameters into this equation, right? So Q sub U is equal to 1.3. C is the cohesion of the soil. If you refer to the diagram or the soil properties, C is equal to 30 kilonewton per meter squared, and then multiply by N sub C, which is 37.16. 37.16 plus, here we have Q multiplied by N sub Q. Q here is the stress at the base of the footing due to the weight of the soil from the ground surface to the base of the footing. So the stress is calculated as the unit weight of soil multiplied by the depth of the footing. So the unit weight of the soil is 18 kilonewton per meter cube, multiplied by the depth of the footing is 1.5 meters, multiplied by N sub Q, which is 22.46 plus 0.4 multiplied by gamma, that is the unit of the soil, 18 kilonewton per meter cube. B is the width of the footing, square footing, 2 meters by 2 meters, so it's 2 multiplied by N sub gamma here, which is equal to 19.13. So take your time to calculate and write down the answer. So you should get the value of 2331.13 kilonewton per meter squared. Right? This is the ultimate bearing capacity. The unit is in terms of stress or pressure, kilonewton per meter squared. After we have obtained the value of ultimate bearing capacity of the footing, then we move on to determine the allowable bearing capacity, that is in part A. Allowable bearing capacity small q sub ALL, allowable bearing capacity, equals to the ultimate bearing capacity divided by safety factor. So in our case, the ultimate bearing capacity that we have calculated before equals to 2331.13 divided by 2.5, safety factor here, equals to 932.45 kilonewton per meter squared. So this is the value of allowable bearing capacity. That is the ultimate bearing capacity divided by safety factor, and the unit is still similar to the ultimate bearing capacity, which is kilonewton per meter squared. Okay, B. We have to determine the net allowable bearing capacity. So net allowable bearing capacity, Q sub net sub ALL equals to QU minus Q divided by safety factor. Okay? So Q sub U here is the ultimate bearing capacity, and Q here is the stress at the base level of the footing, which is the component in the ultimate bearing capacity equation. If you remember the term Q multiplied by N sub Q, the same Q here. Okay? So then it's written as QU is equal to 2331.13 minus Q, which is the stress at the base of the footing, equals to the unit weight of the soil multiplied by the depth of footing. So 18 multiplied by 1.5 divided by 2.5, that is the safety factor. Right, 18 here, I write down here 18 represent the unit weight of soil, and 1.5 here represent the depth of footing D sub F. So Q net allowable equals to 921.65 kilonewton per meter squared. Okay. Q net allowable equals to 921.65 unit still in terms of stress kilonewton per meter squared. So for part C, we have to calculate the allowable load. C, allowable load, written as capital Q sub ALL equal to the allowable bearing capacity multiplied by the area of the footing. So Q, small q sub ALL, that is allowable bearing capacity, multiplied by the area of footing A sub F. So allowable bearing capacity we have calculated in part A. So which equals to 932.45 kilonewton per meter squared multiplied by A sub F, the area of the footing, 2 meters by 2 meters equals to 3730 kilonewton. Okay, take note the unit here. Right? In part A and part B, we were talking about bearing capacity, so the unit is in terms of stress, kilonewton per meter squared. Whereas in C here, we are talking about load, so the unit is kilonewton. Right. Finally, for part D, to calculate the net allowable load, which is equal to Q net allowable, small q net allowable, multiplied by the area of the footing. Alright, so this Q net allowable, the net allowable bearing capacity, we have calculated in part B, which equals to 921.65 kilonewton per meter squared multiplied by the area of the footing, 2 meters by 2 meters. So the value of net allowable load is 36.86 kilonewton. So for part C and part D, both represent load, so the unit is kilonewton. So for this Q allowable, it represents the allowable load from the structure plus the load of the footing plus the load from the soil above the footing. Whereas in case of D, Q net allowable here represents the allowable load from the structure itself. So you can see the difference between allowable and net allowable. Here allowable, gross, total load from structure with of footing, with of soil above footing, and here for the net allowable is the load from the structure itself. Okay. I hope everybody have written down the steps how to solve this problem, and I hope you all understand and know how to solve the problem related to bearing capacity of shallow foundation using Terzaghi's equation. That's it for this session. Until we meet again next time.